So how many of these have you been to?
I have been to all 5 of the Heidelberg Laureate forums, and I really have looked forward to it each time. The interaction with the students means a lot, but I also confess to you that seeing old friends that I would not normally see, except in the context of this event, means a lot to me too. So seeing some of the other laureates it's a special attraction for me too.
So what have you noticed has changed over the last 5 years?
Well, I think, of course, the first year was kind of an experiment. I mean, we had lots of experience. I shouldn't say we, but the staff here had experience with the Lindau meetings for the Nobel Prize winners for going over 50 years. And so they adopted a lot of the practices there that made that flow so well. And I think that made the first one go better than it might otherwise have. There have been small incremental changes between now and the 5th one, but my view is that mostly they got the format right pretty much altogether. They had the lectures, plenary lectures, they had workshops, they had lots of opportunity for interactions in social environments, so it was very casual opportunities. The boat trip is terrific. I mean, it's the one change they made was not getting off the boat and getting back on, because it was time consuming to get everybody back on. You didn't want to lose anybody in the process. So now you stay on the boat. You go some distance on the river and then you turn around and go back without getting off the boat. And that worked very well last year, I thought. So the opportunities for repeated interactions with the students or with other laureates is part of the value of this whole event. And of course, every year there are new students who come, and that means that you have a whole new, fresh opportunity to be exposed to whatever they're thinking about. And I have to tell you that these kids are, because they go through a filtering process to get in the first place, they are incredibly smart, incredibly motivated, poking in spaces where some of us had never been before. Believe me, I get as good as, or better maybe, from them than they get from me, because they're out there like explorers discovering spaces that I haven't been, and then they come back and they tell us, what's out there. And so, although you mentioned mentorship as sort of a one-way thing, believe me, this is a two-way thing. A lot of my thinking is strongly stimulated by what the students have to say.
It's interesting because when we wrote these questions, it was with the idea of, the mentorship is going in one direction.
No, absolutely not. I mean, look, the stimulus of exploratory thinking absolutely goes both ways. I would bet you good money that almost all the laureates have found that their best work is done interacting with somebody else. And certainly that's true for me. I mean, my favorite situation is I'm in front of a whiteboard having a debate or a discussion about something, and we're drawing pictures or equations or what have you, to try to wrestle with a problem, look at it in different ways, make sure we both have the same model before we have a disagreement. That's a really rich form of interaction, and that's what we get here with the students.
So you've been here for 5 years
That's
already.
Right.
And looking forward 5 years, what do you, and having talked with all of these students along the way, what in your field do you think is most interesting to emerge in the next 5 years?
There are certain themes that are emerging. For example, Internet of Things and artificial intelligence have reemerged as a very hot topic these days. Quantum computing is also showing up as a hot topic. So we're seeing social dimensions of the computer networks, the internet in particular, that weren't visible before but are now more visible simply because half the world's population is online. So we're seeing a variety of both technical, sociological, legal, and economic issues becoming clearer and clearer as the network spreads around the world. It spreads unevenly. And it tends to spread where people can afford to use it. And so we have an economic issue in top of an infrastructure question. You know, if you could afford it, but there's no infrastructure, you can't use it. If the infrastructure is there, but you can't afford it, then you can't use it. Fortunately, costs are coming down for the equipment and for the infrastructure, and that's making it more affordable for more people. To say nothing of the fact that the world's GDP is still tending to go up on the average, GDP per capita. So a lot of the issues that are arising are a consequence of this further penetration of software into our environment, our social and economic environment. We also have more and more devices that are programmable than ever before. The Internet of Things, there are predictions which I think are a little excessive, but some people are saying, 50 billion devices by 2020. I don't really know what the numbers are, but I know that the numbers tend to get pretty big. And that just tells us that we will be more and more surrounded by devices animated by software than ever before. And that has both advantages and potential risks.
Now, the things that you're talking about sound like non-technical issues, economics, social, and so forth. And yet the people here are chosen largely because of their excellence in technical fields. So how do you bridge that gap, or what do you think should be done to sort of?
Well, I consider it a big opportunity, frankly, because as a person who has some technical background, but who is seeing very visibly these social and economic effects, things like fake news or misinformation on the net, people being bubble chamber effects, where you have people have aggregated one view, and that's the only view they ever hear, so they never get exposed to anything else. All of these are social effects that we should be worried about. I think part of the job of the laureates, to the extent they care about this stuff, is to alert the technical students that there are issues outside of the technology that they should have on their horizon, on their radar screen, while they're thinking about new technological opportunities, so that we get them to at least be aware that there are problems that are not solely technical in nature, but some of the solutions may actually rest on new technology and new concepts. And I just want these students to have their horizons opened up a bit. It's absolutely true that if you are still working on your PhD, the chances are very good the only thing you care about is separating a topic from the rest of the universe so you can get your PhD done. But we have postdocs here, and of course we have the laureates. So I think there's a lot of opportunity here to paint on the radar screens issues that should be addressed. And if you look at the workshops, you'll find them quite diverse. Some of them are very technical in nature, but others are looking at social and legal questions that the students should be conscious of and even maybe trying to tackle.
That actually segues nice into the whole question of mentorship. How do you get that? How do you make such social issues and non-technical issues resonate, or how do you get the message across?
One way to do this, of course, is to characterize the nature of the technical problem that the social issue exhibits. So, for example, if somebody says, well, there's a lot of misinformation on the internet, and yes, that's true, there is. Some of it's there deliberately, some of it's there because somebody didn't know any better and put some information out that was wrong. And frankly, even scientific information, which is fully vetted and everything else, we discover 40 years later is wrong because we have better models of the world than we had 40 years ago. So what you do is you take what you worry about, whether it's fake news or misinformation or something, and then you start asking yourself, okay, are there any technical ways of detecting that some information is in fact misleading, for example. And we do this in some very specific cases. If you look at email, for example, which is something Google supports, since so much of it flows through the Google system, we see a lot of spam. And we can recognize it as spam partly because the same message is showing up in a whole bunch of different places, all coming from what appears to be the same source, or it may be different sources, but it's the same message, or it's a very similar message. And so we can actually filter some of that stuff out based on the scope of visibility we have. We also look for malware, for example, that might be sent as an attachment. Some of it's pretty subtle. I mean, sometimes it's a spreadsheet, sometimes it's a PowerPoint, sometimes it's a PDF file, which when run against the application software does something bad. And this just tells you that the software is not always perfect and there are bugs that get exploited. So we can combat some of these problems using technical mechanisms to do that. And what I would want to do is to help the students understand that there are problems that they could address from the technical point of view that would solve sociological or economic problems.
Tell me about your mentors.
So I had people who were cast in a specific mentorship role. Two of them in particular, my thesis advisor, Jerry Estrin at UCLA, was very much a mentor in helping me navigate the PhD and get the work done and get it accepted by the committee. I had a partner, Robert Kahn, with whom I did the internet work, and both of us received the Turing Award for. And Bob really helped me work my way into this community. I mean, I was an undergraduate, or I'm sorry, I was a graduate student at the time that I met Bob. By this time, he was already at Bolt, Beranek, and Newman building the ARPANET project, or the packet switches for the ARPANET. And when I went to ARPA, he preceded me and was very helpful in helping me understand, how to go about doing business as a program manager. And then I had a contemporary, Steve Crocker, whom I met in high school, and he and I have worked off and on together, or at least had our jobs intersect with each other. He went to ARPA before I did, and I followed along, and then I became chairman of ICANN. He later became chairman of ICANN. We've had a lot of other interactions. So I've had people even who were essentially contemporary in my age group who were, I consider, mentors of a sort. And it's this mutual interaction that, from my point of view, produces mentorship. I don't think this is a one-way function at all. I think this is part of a conversation that helps you figure out what the problems are, what the issues are, and what approaches there might be to solving the problems. And it's that debate and discussion which produces the mentorship that I'm interested in anyway.
So let's go back to that period, sort of right around undergraduate and so forth. What were those 5 years or so like for you, transitioning from academia to, you were at BBN, yes, or you were at...
Yes,
okay.
I started out in my undergraduate years as a mathematician. So I took the full course of mathematics at Stanford, and then even took some advanced classes as a senior.
And what years would these have been?
Sorry?
What years would this have been?
From 1961 to 1965, I was at Stanford. But I also took as many programming courses as I could in the nascent computer science department. So it was in numerical analysis initially, and then later we had a real computer science department, and we worried about compilers and programming languages and operating system design and data structures and things like that. So I had as much computing as I could possibly fit into the schedule. And when I finished my undergraduate years at Stanford, I went to work for IBM in Los Angeles for 2 years. And I thought this was an important break. Sometimes people talk about gap years. This was my sort of 2-year gap. By the time 2 years had gone by, I had been running a time-sharing system for IBM from 1965 to 67. Now, this is early days for time-sharing. This is really, John McCarthy's group at MIT kind of invented this idea of time sharing on a PDB-1 and brought that to Stanford University in 1962 or something. So to be running a commercial time sharing system in 1965 was actually pretty amazing. So I learned a lot because I dug into the actual operating system code. I was reading machine language, or assembly language, to understand how it worked. And by the end of a couple of years, I realized, boy, I needed to go back to school and get a much better grounding in design. What's an operating system? How does it work? What should it do? What's a programming language? How do you write a compiler for it? So I went back to school at UCLA to get a PhD, and took a whole bunch of classes that were required. And that convinced me that this is a field that I wanted to stay associated with. And then around 1968 or so, the ARPANET project pops up on the horizon, and Steve Crocker and I and John Postel are all at UCLA, all of us incidentally having gone to the same high school. I mean, it's just one of those amazing coincidences. Van Nuys High in San Fernando Valley, north of UCLA. So we're all in, first in Jerry Estrin's group, and then Leonard Kleinrock, who was responsible for the Network Measurement Center of the ARPANET, hired all three of us to do work on that project. So we developed a time-sharing system for a Sigma 7 computer. We developed the host protocols for the ARPANET that ran on top of the underlying packet switching stuff. John Postel ended up being the editor of the RFC series and eventually the manager of domain names and IP address allocation. So we sort of coalesced as graduate students around the ARPANET project. And so for me, graduate school was slightly schizophrenic because my dissertation work was not on networking. It was on multiple processors and figuring out how to take a serial program and convert it into a parallel program to run on different processors concurrently. But my real work was on understanding the ARPANET and the host protocols. And then, of course, I ended up going to Stanford and joining the faculty in 1972. And about that time, Bob Kahn went from Bolt, Beranek, and Newman to ARPA. And he showed up the next year at Stanford telling me that we had a problem getting different kinds of packet switch nets to interconnect with each other in some uniform way. That was the origin of the internet.
So this was, this period of time for you was like your early 20s or so, right? Mid-20s maybe?
Well, late 20s, because remember, I took 2 years out.
Yeah.
So when I started my dissertation work at UCLA, it was 1967, so I was already 24. By the time I finished, it was 5 years later, so I was 29. By the time I got to Stanford, it was late 72, so I'm on my way to being 30 years old. And so the real internet work starts about that point when I'm late 20s, early 30s. And of course, it's continued since then.
Now, this is similar to the researchers here. I mean, they tend to be a little bit younger, I think.
They're I guess. I mean, it's hard for me. They all look like junior high school students, but so I know the last time I was on the Stanford campus, I'm thinking, what are all these junior high students here for? And of course, they're not. They're seniors and whatever. So the answer is that a lot of the kids here are in their early to mid-20s, basically, and of course, full of energy. It's a wonderful time to be, part of the academic world. You don't really know that you can't do that because you're too young, right? So you try it anyway, and that's what is so much fun with dealing with young people.
Now, how different do you think the world is for them than it was for you in the late 60s, early 70s?
Well, they have a vastly larger amount of information and knowledge to draw upon. They have access to it in ways that we certainly didn't have when I was in my 20s because we didn't have an internet and a World Wide Web to refer to. They have bigger aspirations now because so much has already happened, but they also have much more capacity to try things out. So the problems are still just as hard as ever, but their scope may be bigger, and in some sense maybe even more complex.
Any final comments?
Well, I think that one of the changes, which you asked me about earlier, is worthy of mention. Because the Klaus Tschira Foundation supports both the meetings at Lindau of the Nobel Prize winners and the Heidelberg Laureate Forum, the decision to start mixing those people together a little bit, I thought was extremely wise and very refreshing. And so today's lecture from Chicken Over, for example, about medicine and its changes now, more complex possibilities of individual diagnosis and the like, those are things that you should hear because they're not central necessarily yet to your computer science research or mathematics. However, I have noticed that all the disciplines are relying increasingly on computing capability to simulate complex environments or to do computations we couldn't do before. And so slowly but surely, computing and networking are creeping into all of the various disciplines. And in some sense, I think that places a burden on especially the computer scientists to be conscious of the fact that the other disciplines are now relying on them to produce tools that are reliable, that are fast and efficient, and allow insight that we couldn't get in any other way. And so the visualizations that we see today, of course, we see all this computer art, but in fact, that's a manifestation of the beauty that computer programming can produce, but it also tells you that visualization can be a very powerful tool for insight. And so the more other disciplines make use of computing and simulation, the more we can expect people to have realizations and insights they wouldn't have any other way to get. So the computer scientists suddenly owe the rest of the disciplines a lot of care and thought to supporting their work.
That sort of echoes back to what you said earlier about sort of the cross-pollination that between computer science and the world.
Yeah, it's quite fascinating to discover that at some point some of the computer-based modeling and computational tools have led to Nobel Prizes, not because of the computing, but because of the thing that they discovered. So recently, there were 3 Nobel Prizes in chemistry given a few years ago. They weren't doing wet lab experiments, they were doing simulations on a computer to understand certain phenomena. And so for me, that was a real eye-opener that said, computing is now something a lot more than just calculation. It's about gaining insight into complex processes. And we're getting that with the help of artificial intelligence, machine rendering, and high-speed computation.
It seems like a good place to end.
Okay.
Thank you so much
Sure,
for
Tom.